Hello everyone, welcome back to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see the today's problem. Cut rope to maximize product. Given a rope of length n meters, cut it into multiple smaller ropes such that product of their length is maximized. At least one cut is mandatory. So in this question we are given a rope of length n and we need to make cuts in that rope, and we need to maximize the product of the length of every part which is cut. For example, n equals to 2. So since we can make one cut, so after making one cut, the rope will be divided into two parts, which of length 1 and 1. So the product will be 1 into 1, which will be 1. If length of rope is 5, so if we make a cut and divide this length this rope into two parts of length 2 and 3, by subbing we will get 5 and the product will be 6. So the maximum product will be 6 is, and here n equals to 50. So this is a recursive solution. We will try for every cut possible and then get the answer by finding out the maximum product of every part. So let's look at the code here. First of all, we will iterate from 1 to n minus 1 because it is given the question one cut is mandatory. So we will check for making the first cut at of length 1, then 2, 3 and n minus 1. If the rope length is n minus 1, let's say rope length is 4, then we will make the cut of in the end we will make the cut of length 3. So and the remaining rope will be of length 1. So at least one cut is mandatory. That's why we are doing from 1 to n minus 1 and recursively calling for I into the length or the current length into the remaining length and taking the maximum every time by after recursively calling the function and returning that. Let's look at a solve function here. If n equals to 0, it means that we have no rope length. We will return 1. This is the base condition. Let's look at this condition. After making one cut, we have the possibility to make 0 cut now. This function have the possibility to make 0 cut now. For example, if we are given length of a rope of length 5, if we make cut at 2, then for recursively calling for this 3, we have this permission to not cut this rope. That's why we are looping here from I equals to 1 to n. If let's say I equals to n, which means n minus n, which will be 0. So I here will be the length, the total length of the rope, which will be n, and solve will call for 0, which will return 1. So I will be the total length of the rope currently, which is n in the solve function. So in this way we are going to have the total length of the rope. So that's why the loop here is from 1 to n and from here 1 to n minus 1. And in the end we will just return res. For making it a dynamic programming solution, we will be taking a dp of n plus 1, which will be filled with minus 1, and we will be checking if dp of n is not equals to minus 1, then return this dp of n, else we are going to store the resultant dp of n. So this is the whole code here. So guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.